The 767 electrical system is essentially a left-right electrical distribution system with cross-tie capability via the tie bus and the left and right bus tie breakers. The bus tie breakers are controlled by the bus tie switches. The main points of AC distribution are the left and right AC buses. Bus off lights on the electrical control panel indicate the status of the AC buses. From the left AC bus, the AC power is distributed to the left utility bus and to the left transformer rectifier, or TRU, for DC conversion for the left DC bus. The left AC bus normally powers the center AC bus. The left AC bus normally powers the left AC transfer bus, and through it, the standby AC bus. Finally, the left AC bus normally powers the captain's flight instrument transfer bus. The right AC bus performs a similar service. It is the main distribution point of AC electrical power for the right utility bus, and the right TRU for the right DC bus, and the ground service bus. Note, the ground service bus is the power source for the battery chargers of the aircraft battery and the APU battery. The right AC bus normally powers the first officer's flight instrument transfer bus and the right AC transfer bus. In addition to the battery chargers, the ground service bus also powers one equipment cooling fan, the left main tank forward fuel pump, and the left forward entry door. On the ground service bus can be connected to the ground handling bus with a switch located on the forward cabin attendant panel. However, any time the right AC bus is powered or the ground handling bus is unpowered, the ground service bus automatically reverts back to the right AC bus. In addition to the battery chargers, the ground handling bus can only be powered on the ground. Either APU or external power energizes the bus, with external power having priority. External power merely needs to be plugged in. It does not need to be in use or selected on.
The ground handling bus powers the cargo compartment lights, the cargo door electrical operating systems, and airplane refueling.
These buses, the captains and the first officers, have the ability to switch power sources. The left main AC bus normally powers the captain's flight instrument transfer bus, and the right main AC bus, the first officer's transfer bus. In case of power loss of the main AC bus, the flight instrument transfer buses are able to switch to the other side. However, this switching is only possible if the bus tie switches are in the auto position. The left and right main AC buses normally power the left and right AC transfer buses. The only alternate power source for these AC transfer buses is the HDG. Since these AC transfer buses power electrical systems deemed necessary for ETOPS operations, they remain powered in case of a dual main AC bus failure. In fact, when these AC transfer buses switch their power source to the HDG because of loss of power to both main AC buses, the left AC transfer bus contactor not only maintains power to its bus, but also applies power to the captain's flight instrument transfer bus. As indicated earlier, when there is only one electrical power source available, the left and right distribution systems can be powered through the two bus tie breakers. For this purpose, the switches have to be in the auto position with auto indicated. In fact, you should never move the bus tie switches from the auto position unless directed by an abnormal or non-normal procedure. The isolation position of each bus tie switch has an effect on other electrical components. The following priority determines which power source is applied to the AC bus. Respective engine-driven generator, APU generator, opposite engine-driven generator. External power must be manually selected. Pushing the external power switch to on replaces APU power, or engine-driven generator power, with external power. This will be the case, for instance, at gate arrival when external power is plugged in and the available light is illuminated. On the other hand, on engine startup with external power still powering the buses, the engine generator automatically replaces external power on the respective AC bus. Back to the bus priorities. Here we show both engines running and the generators online. If an engine-driven generator fails, the opposite generator or the APU generator, if available, will automatically take over. When a generator cross-ties from one side to the other side, the utility buses are shed. We now start the APU. As soon as the APU comes online, run light illuminated, the APU generator automatically replaces the opposite engine's generator as the power source. The utility buses are now powered since there is no crosstie. The fact that the APU generator has taken over from the opposite engine generator can be inferred by both utility bus off lights having gone out.